Today we're going to be talking about polar coordinates. Now, before we do that, you have to understand that your understanding of a coordinate system xy, that is called rectangular coordinates. And this is actually one of many systems. So the one you know is just the most popular one. And think about why it's called rectangular. If I were to give you a point, let's say 2, 3, you go 2 to the right, 3 up, there's your point. Instead of going 2 right and 3 up, you could have gone 3 up and 2 right. So this thinking is rectangular thinking, and that's why we call it rectangular coordinates. Today we're going to be doing what's called polar coordinates. And polar coordinates focuses on trigonometry and focuses on this idea of a circle. So it's going to be circular thinking. So I'll show you how that works right here. So underneath our example here, polar is going to be r comma theta. And the way this works is r is the distance from the origin, and theta is your rotation. And just like the circle, if you start by going up, that's going to be your positive rotation, that's counterclockwise. If you go down first, that's going to be negative, or that's clockwise rotation. And that's pretty much all you need to do polar. So let me show you how to do this. A couple tips here is you always start with theta. That's going to help you graph these. So for letter A, it's 3, 5 pi over 3. What I want you to do is imagine, let's look at this right here. Think of this as a bird's eye view, and imagine you're standing right here. So imagine that's the top of someone's head. We're going to graph this point, 3, 5 pi over 3. We're going to look at 5 pi over 3, that's right here. So imagine this is you, you're looking at this 5 pi over 3. Okay, so you're looking at this, you're standing right here. With that 3 right here, this 3, that means you just take 3 steps towards 5 pi over 3. So each ring is 1. So let's go 1, 2, 3. And there's your dot. There it is. So that's letter A. We graphed it. Let's try another one. 2, negative pi over 4. So I'll do this in red. So again, look at your angle. So rotate negative pi over 4. That would be right here. And imagine you're standing here. It says take 2 steps forward. So stay on the 7 pi over 4 line and just go 2 steps. 1, 2. There's your point, B. Okay, next one. I'll do this in green. 3, 0. So don't get this confused with rectangular. This is a polar coordinate. Look at the 0. You're standing at the origin. And just walk 3 steps forward. 1, 2, 3. There's your dot. Notice how it is the same as a rectangular, but that's purely a coincidence. And the last one, I'll do this in purple. Pi over 4, negative 2. So that means we're looking at pi over 4. You're standing at the origin. But r is negative 2. So instead of walking forward, we're going to walk the other direction, backwards. 1, 2. There's part D. And there you go. We just graphed our first set of polar coordinates. Okay, now let's kind of expand on this idea. 2 pi over 4. So at this point, we should be able to locate that pretty easily. Look at pi over 4 and walk 2 units forward. 1, 2. What we're going to do is try to think of multiple ways to get to this point. So think of this point as like our goal. We want to find other representations of this. So for example, what if I did 2 and 9 pi over 4? Because 9 pi over 4 would mean you just add 2 pi, right? Just rotate another time. That'd be the same point. Now what if I also did 2, and let's say negative 7 pi over 4. Because negative 7 pi over 4 would mean if you go here, you rotate in the opposite way and then go 2 forward. So that would work. I can try another one. I can try, let's say r is negative 2. So negative 2 means you're going to walk backwards, which means you actually want to face the opposite direction. I'm going to try to face this way. So that would be 5 pi over 4. And let's say I asked you a question like, how long could we keep creating these other situations or these other answers? And the answer is forever. There are infinite representations of a point in polar, whereas in rectangular there's only one representation. In polar we can actually do this forever. That's why polar is a little bit more complex. So in this next one, let's take a look at this. It says plot the polar point 3 pi over 6. Let's plot that. Pi over 6, go 3 out. 1, 2, 3. So there's our point. And then it gives you specifications. So it's kind of like the last one, except what we're going to do now is just kind of create the point with the guidelines given. So for A, it says R must be positive. So just keep R the same, 3. But look at this, theta is between 2 pi and 4 pi. So let's just take pi over 6 and just add 2 pi to it. Just add 1 rotation. That'd be 13 pi over 6. So again, that's another representation of this point. B, it says R is negative, so let's make that negative 3. But theta is positive. So that would mean we got to figure out how do we get to this point right here. This is our goal. How do we get to that point if we're going to walk in the opposite direction, but we're still rotating the normal way? Well, think about it. That would mean you'd have to rotate all the way to here, 7 pi over 6, because then if you're looking at this direction, negative would shoot you in the opposite direction. So that must be 7 pi over 6. And the last one, it says R is positive. So let's make that 3. But now, this is important, really highlight that. Theta is negative. So that would mean we're going to walk forward, but we have to rotate the negative direction. So let's look back here. We got to rotate the negative direction, and then we're going to walk forward to our goal. So think about, what is that angle rotating negative? Well, that would be negative 11 pi over 6. That's it. That's polar coordinates.